Welcome to solverfy.
Okay, we have a rather large molecule, but I will draw it nonetheless. It takes a moment. So we have a phenol group that is a benzene ring with an OH attached or a hydroxyl attached. We have an amine. We have an alcohol. We have another phenyl ring. This one with a carboxylic acid attached. Oops. And all of the alcohols are actually alkoxides. I just drew them as alcohols because I forgot. Right, so they actually have negative charges and not protons. And here we are. And the question is, of the four circled groups, let me circle them. Which is the most basic? Okay, well, I would argue that any of the oxygen species are more basic than the amine because they are charged. Charged species, specifically negatively charged species, are always more basic or hungry for a proton or nucleophilic, but not really, but more so just basic than a neutral species. Charge, more basic than neutral. Right. For that reason, we're just going to ignore the amine and look at comparing the three negatively charged oxygen species. And what I would point out is that this negatively charged oxygen is actually in resonance, right, with the carbonyl oxygen. Okay. Which is to say that the negative charge is stabilized. Resonance stabilizes negative charge. Now, this negatively charged oxygen is also stabilized through resonance with this phenyl ring, right? We can distribute this negative charge to three locations throughout the ring. And so we have more stabilization here. So let's then also make this comparison. It's not that we need to rank them, but in fact, the stabilization due to the carbonyl is greater than the stabilization due to the phenyl. And that is because the stabilization due to the carbonyl puts the eventual negative charge after it moves onto another oxygen, which is far more electronegative than the carbons that the phenyl ring resonance puts the negative charge on. So that's just a little aside. The carbonyl is more stabilizing than the phenyl. That's all. Okay. Nevertheless, what the point of this is that this alkoxide has no stabilization granted from any kind of resonance or nearby electronegative groups. Right? That is to say, this oxygen is stabilized through resonance. This oxygen is stabilized through resonance, and this oxygen is unstabilized, or let's just say unstable. And if an oxygen is stabilized with its negative charge, that means it is less basic. Resonance stabilizes, which implies less basic. Why is that? Well, an oxygen with a negative charge that has nowhere to put it, nothing to share it with, is very unhappy and it really craves a proton, right? That's what makes it basic. It's got no other resort. Unless it finds a proton, it's stuck with this negative charge. These oxygens have options, right? They can pass that negative charge around. It gets delocalized over a larger area. The whole phenyl ring in this case, 3 atoms in this case. So there's less concentrated negative charge. And in actual fact, we would say that the lone pairs are lower in energy and less reactive. This lone pair is higher in energy and more reactive. Therefore, this oxygen is more basic. And so this is the, I guess C is the answer.